All right. So last time we talked about if statements and selection structures and how they work and stuff. So today let's get a little practice actually writing some. It's one thing to look at an if statement and evaluate it and stuff, but sometimes it's a little more challenging to actually think about it and have to write your own from scratch. Okay, so this is just kind of a little activity that I've been doing for a while. I didn't come up with these problems, but these will give us a little practice actually writing some if statements. So you'll need to get on a computer. We'll need the compilers for this, obviously. And we'll just kind of do this together and get some practice writing some if statements. And also, if we have time, we'll do a switch statement as well. Okay. So go ahead and log in and load up a compiler, a new thing. So I'm gonna, like I said, you can use dev C++ for this. That's fine. That's probably what I would do on these machines. I'm gonna go ahead and try out this code blocks compiler again. So remember, in dev C++, all you have to do is go to File and New Source File. You don't have to do a project for just a simple thing like this. In code blocks, you have to do a project, I believe. So I'm going to load up code blocks. All right, and then I'll create I'll go to File and New Project. And do a new application project, or sorry, new console project. Console project. Go. And next is a C++ project. I'll give it a title. I'm going to try not to put any spaces in my names. So I'm going to call this if practice. And then click finish. All right. And I can get rid of the hello world line. All right. So I'm just gonna put some comments up at the top to start us off with. So again, if you're in dev, you'll have to type all this stuff probably from scratch. So I'm just going to put / and then a bunch of asterisks. And then at the end, I'll do a bunch of asterisks. And then a / like that. And then maybe just something like a program. I'll maybe put like selection structure practice. Okay. Then you can put your name, not my name, but your name. And then maybe what compiler that you're using. So this is the code blocks compiler. Well, it's the code blocks IDE. So that's what I mean here. Code blocks. Okay. So most of you are probably using dev C++. So you put dev C++. All right. And our include files. So obviously we need IOStream. So you need to put number include IOStream there. Other things we might need, maybe IO manip, in case we want to use set width or something in there at some point in time. I don't know if we will or not. We might not. And then you'll have that line using namespace, and then your int main, open and close curly brackets, and return 0. And again, that much should compile and run. There you go. So that'll be kind of our starting point. Okay. Now inside of main, I'm going to put there at the beginning, I'm going to make a comment, and I'll just put something like variable declarations. I'll try to declare all my variables up here. Everybody have that? All right, so these are just some little activities to give us some practice writing some if statements, and maybe hopefully to get us thinking about if statements and thinking about logical expressions and stuff like that. So the first one says, input 2 numbers and write out the larger of the 2, or maybe output the larger of the 2. So we've got 2 numbers. So we need a couple of variables. So let's just make these integers. So I'm going to declare a couple of integers here. Int num1 and num2, okay? And I'll put a comment here. So this is number 1. They're not numbered on the sheet, but I just numbered them in pencil. So we'll say this is number 1. This is the larger of 2 numbers. Okay. So obviously we need to input these first. That's pretty easy at this point, right? We've done that before. So maybe ask your user to enter in 2 integers. You could have made these doubles or whatever. I'm just going with integers. So cout. We can ask for them at once, or we could ask for them separately. However you want to do it. We'll just get them both at the same time, okay? Enter 2 integers, and I will output the larger. Or largest. Largest? Either way. And then, so that's a cout, so we have a cin to input that, right? So we said we can get them like this. Right, so cin num1 and then num2. So that will expect us to maybe put a space in between the 2 numbers, or type the first number and then press enter, then type the second one, right? Either way. So you could test that out and see what that does. So it outputs enter 2 integers, and I will output the largest. So you could just type in 5 space 6 or something like that. And so it stores those into num1 and num2. Right? Nothing new there. So how would you write an if statement that would output the larger one? So it'll look something like this, right? If something, do something, else, do something else, like that. Okay. So what goes in there? So we have to test something, right? Any thoughts? Was it? Right, so if num1 is greater than num2, so if num1 is greater than num2, see out num1, right? Like that, maybe with a indel there. And then maybe else see out num2, right? Easy enough, right? What do you think? You think it works? I think that should work okay. Let's test it. So we type in two numbers, maybe 4 and 5, and output's 5, right? Or if we do one is control F10. I do function. So if I did 5 and then 4, still get 5, right? So can you think of another scenario? Maybe when they're both equal. What happens when they're both the same number? Five and 5. Well, it outputs 5, right? If they're both the same, they're both the largest. Which one is it actually outputting if they're equal? Is it technically num1 or num2? Yeah, so it'd go to the else part, the way we have it written right now, right? So just plug in the numbers, right? If 5 is greater than 5, well, that's false. It's not, right? So it's going to skip down to the else, and it will output num2, which is fine for this one because, you know, they're the same, so they're both the largest. So this would be fine. You could, you know, modify this to make it, you know, if you were curious, if you wanted to know that they were actually both equal, you could do that. You could do something like this. You could test. Oh, by the way, what if I had done this? If num1 is greater than or equal to num2. That also works, right? But if they were both equal, and this time it would actually output num1. It would hit the true path and do that. So you wouldn't really see a difference, right? It would end up being the same. Anyway, but what if you actually did want to know if they were equal? You could test for that. You could say if num1 is greater than num2, see out num1, else if num2 is greater than num1, see out num2, and then have another option. If that one's false, you can say else see out maybe something like numbers are equal, right? Like that. Then it would actually specify. It would actually tell us that they were equal. So the first if would be false, the second if would be false, so it would skip down to the third option, the else. Numbers are equal. So, you know, so there's some different ways to write that. And you'll see that with if statements. You know, there's different ways to write if statements, and there's different ways to write what I call logically equivalent if statements. if statements that will give you, that are written differently, but they will always give you the same results, no matter what numbers or what values you throw in there. Of course, we modified this one a little bit with the testing free, or the third equality option or whatever. But anyway, so what do you think? Pretty cool? Everybody get that to work? No. No? Okay.
I don't know what's wrong.
All right. So how about the next one, number 2? So what I'm going to do here, just so we don't have to, I'm going to go on to the next one. I'm going to comment this one out so that we don't have to do this again. We don't have to enter in the first 2 numbers again, okay? So what I'm going to do is I'm going to go up to, I'm going to leave the variable declarations, but I'm going to go up to before I inputted the numbers, and I'm just going to put /*, okay? And then I'm going to go to after the if statement and put */. So that's a block comment, right? So I commented out that entire section. So now it's not going to get done. It's not going to execute those statements. So I'm going to do that kind of after we finish with one. I'll comment that one out, and then we'll go on to the next one. But again, I'm going to leave my declarations up there. All right, so number 2, the second one, it's along the same lines, but it says input 3 numbers and print the largest number. So instead of 2 numbers, we're going to have 3 numbers. It's going right? Okay. So we need a num3, right? If we can reuse num1 and num2. So go up there to the top on your variable declarations and just add a num3, int num3. Okay, so now we have a third one. And then down here, I will put another comment. So this is going to be number 2, I think. This is the largest of 3 numbers. So we'll start it the same way. We'll ask the user, enter 3 integers, and I will output the largest. Something like that. You could have even copied and pasted that line. And we'll do cn num1 and num2 and num3 like that. So just like we did before, except this time we're getting 3 numbers. Okay. And again, that should compile and run. So we're getting 3 numbers, 4, 5, and 6 or whatever. So how would you write an if statement that would output the largest of the 3, right? So this one's a little bit more complicated, right? Because now you have 3 numbers. So there's different scenarios, right? One scenario is you have all 3 numbers are different, right? All 3 numbers are different, so clearly there's one that's larger than the other 2. But then you might run into a situation where you have 2 numbers that are the same, right? And those 2 numbers that are the same, they might be the largest, or those 2 numbers that are the same might be smaller than another number that's the largest, right? So that's a couple of scenarios. Another scenario is that all 3 numbers are the same, in which they're all the largest, right? So we're not going to try to figure out how to output any kind of message that specifies that they're equal. Well, you could do that if you really wanted to get into it, but we won't make it that complicated. But we'll just use, if we use the greater than or equal to, that will take care of a lot of that possible equality issue. So does anybody have any ideas? If it's a little harder to write them from scratch, right? You have to think about it a little bit. So what do you think? We got num1, num2, and num3. So one scenario is that num1 is the largest, or at least tied for the largest, right? So how would you write that scenario?
Num1 is greater than or equal to
num2, right? And yeah, so don't forget, we have those logical operators that we can use to combine things, right? So if num1 is greater than or equal to num2, and remember there's two ampersands, num1 is also greater than or equal to num3, right? If that's true, then num1 is the largest, or at least tied with one other or both to be the largest, right? So we could output that, like C out num1. Everybody see that? So remember the things that we have available to us. We have all of our relational operators, like greater than, less than, greater than or equal to, less than or equal to, which is two equal signs, remember, and not equal, exclamation equal. Right, so we have all those relational operators, but we have those logical operators too, like not, and or. Right. So remember how and works? If both of those things are true, then you get a true, right? So both things have to be true. True, and the only way to get a true out of an and is if you have true and true. If either one is false, the whole thing is false. So if num1 is greater than or equal to num2, and num1 is also greater than or equal to num3, then num1, we're going to output num1 because it's the largest, or at least tied with being the largest. Right? So that's one scenario, that num1 is the largest, right? And we could test that. So like that would be something like 6, 5, 4, right? 6 is the largest, or it could be oops, sorry. Or it could be you know, something like 5, 5, 3, 5, right? It's tied with the largest, right? Or maybe it's maybe they're all the same, right? But if it's something like 5, 6, 7, or even 5, 6, 6, right? And you can always just plug in these numbers, right? If 5 is greater than or equal to 6, well, that's false, right? So you're going to have a false and something, so the whole thing is going to be false. So we won't get, so it won't take the true path there. So that's the true path, right? So that's one scenario. Num1 is the largest. But we're not done, right? If that's false, if that's not the situation, then maybe num2 is the largest. So we could test that, right? So we could test, okay, else if, and we do the same thing. If num2 is greater than or equal to num1, and num2 is also greater than or equal to num3, right? Then num2 is the largest, or at least tied as the largest. Okay. And that's how you have to do it. There's no shortcut way of writing that. You can't do something like num2 is greater than or equal to num1 and num3, right? You can't just like you can't shorten it or anything like that. You have to write it all out, type it all out. And also one other thing, in as far as parentheses, I should mention, the only set of parentheses that you technically have to have here are the outer ones. The outer ones around the whole condition, around the whole logical expression. A lot of times I like to put inner parentheses just to kind of show, to maybe make it a little more readable. But again, you don't have to have these inner ones. But I like to put them just to make them a little more readable. Of course, you have to be careful. For every open parentheses, you have to have a closed parentheses, right? So that could get a little tricky if you have a whole bunch of open and closed parentheses and stuff. Close. Like that, and always test it. So we're testing to see if the second one's the largest, right? So maybe 4, 6, 5. The 6 is the largest. It works. And that will work as long as num2 is the largest, or at least tied. Right? Of course, if num2 is tied with num1 as being the largest, it's not going to get down there, right? That first if statement is going to recognize or pick up that num1 and num2 are equal as being the largest. That makes sense? So what have we not covered? Right, so it works as long, except for when num3 is the largest, right? So we don't have a num3 option. And really, the only scenario that's left is that num3 is the largest and not tied with anybody else, right? If num3 was tied with somebody as being the largest, one of the first two if statements would have picked that up. Or if they were all equal, right? But it doesn't handle the scenario if num3 is the largest by itself. So there's only one scenario left, and that's if num3 is the largest by itself. So we could just have an else by itself if we want to. Else cout num3 like that. Of course, you could always test that if you wanted to. You could also throw in, else if num3 is greater than or equal to num1 and num3 is greater than or equal to num2, then do that. But technically, you don't have to down here because it won't get to this third option unless that's true, right? Or unless that's the scenario. So what do you think? Are you talking about the inner parentheses?
Yeah, like maybe put if and after the parentheses put enter and open a bracket.
Okay. So you're saying like this, they'll have open curly bracket like that, and then have that in there. So yeah, good question. So it's like that. So yeah, that's a good time for me to mention this. And I think I mentioned it on Tuesday as well, but it's important enough to go over again. If there's only one statement that goes with an if or an else statement, you don't have to have curly brackets grouping anything, right? So the way I had it is that only the next statement, the next action statement, the cout, would go with the if or the else or whatever. But if you had more than one statement that needed to go with the if or the else, you would have to put that those two statements inside of curly brackets. Like if you had another statement that needed to go there, like see out this was the num1 tree path, or whatever you're going to do there, okay? Like that. If there was more than one statement that needed to go with that if, or in the same thing for the other else's and stuff, you would have to make sure that you have those inside of curly brackets to group them together. So let's try that. So that's if num1 is the largest, like that. So 5, this was the num1 tree path, right? So if you were doing something like that and you didn't put your curly brackets, what would happen? And we can leave the indentation. Indentation doesn't matter. It's just there for readability purposes. On this one, I'm going to end up getting an error because what it's going to do is it's going to think this is an if statement. If this is true, it's going to output num1, and then it's going to think the compiler will think it's finished with the if statement. Okay? And then, so it's going to think it's just a one-way selection if statement with no else, no false path. Okay? And it's going to output, this was the num1 true path, but then it'll get to this else down here, and it won't have an if to match up with it, because it'll think that it was finished with the previous if. It'll say something like if without an else. See, I got my error there, and the error message was something like else without an if. I have it backwards. And you can have an if without an else, but you can't have an else without an if, right? Else without a previous if. Sometimes that's called a dangling else, I believe. So let me put those back in. And so if you only have one statement that goes inside an if statement, you don't have to use curly brackets, but you can, right? You can always have curly brackets with one statement in there. It's just not necessary if it's one statement. Yeah. Now, if I'd done something like that down here, let's look at this. See out, this was the num3 tree path. What's that going to do? Well, you might look at that and think, well, that's pretty much the same thing, right? It's, right, so will that give me an error on that particular one? Yeah, so that one won't end up giving me an error because it's not going to run into an else without an if afterwards. It will just output, this is the num3 true path every time, no matter what it is. So let's test it. So I do, let's do the num1 true path, right? So 5, 4, 3. So the first if part was true, right? So it outputs 5. This was the num1 true path. It doesn't do the other else's. So it skips to the next statement after the nested if statement, which is that line that says this was the num3 true path, because it's after it. So it doesn't matter if it's indented or what, right? It's basically thinking it's like this, right? The indentation in there it doesn't matter. It doesn't make a difference on how it runs. So you always have to group things together. Any questions about that? All right, I'm going to get rid of that. So that's what we had, right? Yeah, so one error that is easy to make is, just about the time you get used to putting semicolons places, there's places where you don't put semicolons, right? So you don't put a semicolon after an if statement. So what happens if you accidentally do that? And that sometimes that's hard to spot, right? Especially if you have a longer program or something like that. And it's the same thing on loops. When we get to loops, it'll be the same way. So suppose you have that semicolon there. Well, now we'll get an error because what it's thinking on that second if, else if num2 is greater than blah, 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 it'll basically think that, that semicolon there is basically like a statement that doesn't do anything. So, but it's basically, that's the true path. The semicolon will be the end of the true path, and then the next statement is cout num2. That it's like what we saw just a minute ago. That's like a statement after the if statement, and then it'll get to that else and not have an if that matches up with it. And that is so easy to do. So the problem is that semicolon. All right, let's go on. All right, so I'm going to comment this one out just like I commented out the first one. So I'm going to go to right before it and put a /*, and then afterwards I'll put an asterisk /. So now that's commented out as well. And so now let's look at the next one. I'm going to comment here. This is number 3. It says, develop a program that asks the user to enter an integer. The program should then state whether or not that integer is evenly divisible by 5. So this, I'm going to call this one divisibility tester. Okay. So we could just use like num1. Num1 is declared as an integer, right? So you want to make sure that you're doing integers, because remember, in C++ you can only use modulus with integers. And so let's just do that. We'll ask cout enter an integer n, and I will see if it is divisible by 5. And then just cn num1. Using num1. So how could you test to see if that integer is divisible by 5? Can it end up looking like this? Any thoughts? Right. Mod. I kind of gave that away, didn't I? When I mentioned that about modulus. So sorry about that. I didn't mean to give away the secret. So yeah. So on this one, the key is to use the modulus operator. And what does the modulus operator do? Right. So it returns the remainder after you divide two integers. Okay. So if we did something like if num1 mod 5, that's what we're testing to see if it's divisible by. How do we know if it's divisible by 5 once we do that? Right, so if the result is 0, right? So how would you write that? So you wouldn't want to do this, right? That's an easy mistake to make. Equals 0, it's 2 equal signs, right? So if num1 mod 5 is equal to 0, then if that's true, it's divisible by 5. Divisible by 5. Cout, I'll do this. Num1 space is divisible by 5. else, I got my else there. See out num1 is not divisible by 5. So there you go. So there it will actually output the number that you typed in, followed by a message is or is not divisible by 5. So let's test that. Divisible by 5. Not.
So if it was a double, would that be like 0.0?
So if you tried to do that with a double, like if num1 was a double, you'd probably get an error on that, I believe. At least in C++. It probably won't let you do that. Even if it's 4.0. Yeah. It says invalid operands of types double. So it has to be an integer. Sorry, num1. Cool. Of course, this is how the compiler does it. It can use the modulus operator to do that. Of course, we as humans, we're kind of clever, right? We've come up with little divisibility ruled shortcuts. So 5 is easy, right? How can you tell really easily just by looking at a number if it's divisible by 5? Right, if the last digit is 0 or 5, right? So it's pretty easy on 5. And so, but that's not how we're doing it here. But do you guys know your divisibility rules? I always thought those were kind of cool. So this is kind of off subject, but a little bit. What's the divisibility rule for 2? That one's easy, right? Just if you just saw a number and ask you, is that number divisible by 2? Right, so you look at the last digit, right? And so if the last digit is divisible by 2, if it's an even number, right, then the whole number is divisible by 2, right? Do you know the rule for 3? I think this was like a number sense thing, which I was always horrible at number sense, UIL number sense in school. Did anybody do number sense? We don't have any number sense people. Calculator was my thing. I could never do stuff in my head. Still can't do stuff in my head very well. But you give me some kind of device, then I can handle it, right? So that's why I'm a computer science. Actually, I was a math major, but I still needed my calculator. Anyway, what's the divisibility rule for 3? Anybody remember that one? So it's kind of cool. So the divisibility rule for 3 is if you add up all the numbers, all the digits in the number, if the sum is divisible by 3, then the whole number is divisible by 3. So I take like something like 27, right? 27 is divisible by 3, right? So 2 plus 7 is 9, and 9 is divisible by 3, right? So the same thing works even if it's like a larger number, right? 27 is easy. We know that one. We memorized that one, right? But if you took a larger number, the same process would work. You add up all the digits. How about 4? You guys remember 4? It's a lot like 2. But a number is divisible by 4 if the last 2 digits are divisible by 4.
I never learned these rules.
Yeah, you remember this?
No, I never.
Oh, you never learned them? Oh, okay. Well, election years, that's a good example to look at, right? Presidential election years, right? The presidential election years are divisible by 4, right? So the last presidential election we had was 2016, right? Take the last two digits, 16. 16 is divisible by 4, right? This is 2018. 18 is not divisible by 4, right? So no presidential election, whatever. How about, well, we know 5, right? We just said that one, right? If the last digit is 0 or 5, then it's divisible by 5. How about 6? You guys know 6? So 6 is kind of cool. It combines the rules for 2 and 3. So a number is divisible by 6 if it's also divisible by 2 and 3. So you just check to see if it's divisible by 2, look at the last digit, and then check to see if it's divisible by 3, add the digits together, and see if that sum is divisible by 3. If both of those are true, then the whole thing is divisible by 6. Right? I'm going to skip 7. 8 works just like 4. You look at the last 3 digits. If the last 3 digits are divisible by 8, then the whole thing is divisible by 8. 9 works just like the rule for 3. You add up all the digits, and if that sum is divisible by 9, then it's divisible by 9. Like 81. Look at the number 81. 8 plus 1 is 9, so it's divisible by 9. 10's easy, right? If it ends in 0. There's a rule for 7 and 11. I can never remember that stupid rule. It's more complicated. I looked it up the other day, or in the other section. Okay. Divisibility rule for 7. It's more complicated. Oh yeah, okay, I remember now. To check if a number is evenly divisible by 7, take the last digit of the number, double it, then subtract the result from the rest of the number. Okay? If the resulting number is evenly divisible by 7, so is the original number. So that one's a little bit harder to remember, right? So it's something like, give me a number that's divisible by 7. That's larger than something. So just what's 7 times? No, it's not big enough. 7. Just say 7 times 100. Okay. Well, let's do a different one. 7 times 241. All right. So is the number 1,687 divisible by 7? So what does the rule say? Let's see if I remember how to use it. Take the last digit and double it. So the last digit is 7. So double is 14. Okay. Subtract that from the rest of the number. So 100. Write down my number. So 168 minus 14 is 154. So if that number is divisible by 7, the whole thing is divisible by 7. Of course, you might not know that right off the bat, right? So I wonder if you could do that again. So if 154 is divisible by 7, right? So take the last digit, and that's 8. 15 minus 8 is 7, right? So 154 is divisible by 7 because that number was divisible by 7. That original number, 1,687, is divisible by 7. So anyway, that one's harder, right? But anyway, that's how it works. And like I said, there's one for 11. I forget it. I don't know if I want to go into that. Take the alternating sum of the digits in the number read from left to right. If that is divisible by 11, so is the original number. So 2728 has alternating sums of the digits. Let's see, 2 minus 7 plus 2 minus 8 is minus 11, and that is divisible, so the original is 2. Anyway, those are little number sense shortcuts. So what does that have to do with what we're doing? Well, not all that much, but but that's not how we're writing this, right? But you could do something like, what if you were doing some kind of program that had like really, really large integers that were too large for the integer data type? Well, you might have to come up with an alternate way of solving that problem, right? So maybe you could use like a one-dimensional array of integers where every element in the array was a integer digit of the number. You could use your little shortcuts to do something like add all the digits up or something. But that's beyond what we're talking about here. So, any questions about this one? Okay. All right, I'm going to comment out this line. Let's do the next one. Or comment out this section. All right, so the next one, this is the range tester, okay? So I'm going to put a comment. This is number 4, range tester. All right, so this one says, and the wording on this is a little vague, but I'll explain what I want here. Develop a program that reads an integer and determines if it is within a given range, for example, 1 to 10, okay? But then it says the high and low values of the range should be entered by the user rather than fixed by the program, okay? So we're going to input 3 things. We're going to input the low range and the high range and then the number for range testing. And so let's go ahead and declare some new variables for this. So int low, let's name it low, int high, and then int, let's name it number, okay? Technically we could have used one of our num1, 2, or 3 earlier, but we'll just go with new ones, okay? And then I'm going to ask the user to enter each of those in. So cout, enter the low range, and I'm going to get it, cin low, and then cout, enter the high range, and cout, enter the number for range testing, and cin number. Something like that. Enter the low range, and if you didn't want to do that, you can do that. Oh, I screwed that up. Okay, like that. So how would you test to see if number was within the range from low to high? Okay, so you have to decide, okay, does the range include the low and the high, or does it have to be in between? So that basically just amounts to, are you doing you know, less than, greater than, are you doing like less than or equal to, or greater than or equal to, or whatever? Okay. That's not going to affect the logic of what we're trying to do here very much. So how would you do that? So one initial thought might be this, and I talked about this some on Tuesday. You've seen stuff like this in mathematics before, probably. Something like if low is less than or equal to number, which is less than or equal to high, like that, right? You've seen stuff like that before, you know, in your math courses and stuff. And you might think, oh, okay, maybe I can write it like that. So if it's within that range, see out something like number is within range. Else, see out number is not within range. And that should compile and run, but there's a problem with it, right? So basically you can't write it like that. And if you remember, we said that will always evaluate to true, actually. So just to show you what I mean, we can do like 1 to 10. So it works fine for something like 5, right? Number within range. And you might think, oh, cool, it worked. But then if you test it with some other numbers, maybe 11, which is not within the range, right? It says number is within range. So it was true again. Or a negative number, right? Or maybe a 0. That's not in the range, but it says it's within the range. So why is that? Well, the problem is how we wrote it. Yeah, so it's like this part. This first part is going to evaluate this first, right? Exactly. We have to split this up into 2 different parts because that first part, it's going to return a true or a false, right? But when it returns a true, that's basically returning a 1. And a false is a 0, right? So that first part is going to return a 1 for true, 0 for false. And as long as high is a positive number, right? It's going to return, that's going to be less than or equal to high. So that's going to be true, right? The only way that you're going to get a false out of that is if you do something like enter a negative number in for the high. Which wouldn't really be a range, right? Right? Or like crisscrossing our ranges or something like that. But if you did something like, you know, this would be a range, what, like negative 10 to negative 1, and you put a number that was in that range, like negative 5, it's going to tell you that it's not within the range. Because that first part is going to return a 0 or 1, and then it's going to test that against high. Right? So we can't write it like that. So it compiles and it runs. So it's not a compile or syntax error, but it's a logic error, right? I didn't write it the way that it needs to be written in order for it to accomplish what I probably want it to accomplish. So you got to split that up into two different parts. So you can write it, there's a few different ways you can write this. I'd probably choose to write it like this. If number is greater than or equal to low and number is less than or equal to high, then it's within the range. Okay. And again, you don't have to have the inner parentheses. You have to have the outer ones, but if you want to have the inner ones, you can. Close. Yeah. like that. And so now it will test it correctly. So again, 5 is in the range, right? But let's check some that aren't. 1 to 10, and then like 11. 11 is not in the range. To 10, and then 0 is not in the range. And you know, to evaluate it, sometimes it just helps to plug in some numbers, right? To say 1 and 10. So check 11, right? If 11 is greater than or equal to 1, that's true. And 11 is less than or equal to high, which is 10. 11 is less than or equal to 10. That's false, right? So you have true and false, which is false. So there you go. Does that make sense? So you got to be careful with that range testing stuff. How'd that go? Okay.
I did something to this. I don't know how to get it back.
Okay.
I made like it this big.
All right. So real quick, I think I'm gonna skip this next one. We might come back to it or something. I'm gonna comment this out. So let's do the triangle one. So this is number 6. Like I said, we might come back to number 5. Number 6. This is triangle tester. So number 6, develop a program that reads 3 positive integers representing the sides of a triangle and determines whether they form a valid triangle. Okay. The hint is, in a triangle, the sum of any 2 sides must always be greater than the third side. So we're not talking about like a right triangle or an isosceles or anything specific. This is like a general rule for any kind of triangle. It could of any shape, as long as it's a triangle, right? So it's a triangle if it has 3 sides that come together and you have 3 vertices, right? Or whatever, right? So you don't have something weird like a triangle with an extra piece sticking out or something is what we're talking about, okay? So how would you do this? So we need a few variables. I'll just do like this, int s1, comma s2, comma s3. So you can do that. You can declare multiple variables of the same data type on the same line. So we have S1, S2, and S3. And we can ask the user to enter those in. Cout, enter 3 integers, and I will test if they can form a triangle. And then we can just do cn s1, s2, and s3 like that. So what would your if statement look like on this? Well, at first thought you might think maybe something like this. S1, if S1 plus S2 is greater than S3. So it said the sum of any 2 sides has to be greater than the third side, right? So you might think that at first. Okay, I'm testing to see if S1 plus S2 is greater than S3. Maybe output a message like cout valid triangle else cout not a valid triangle. So let's just take some numbers, plug in some numbers. We know, what is like a right triangle? Isn't there another name for it? It's like a 3, 4, 5 triangle. Is that right? Have you ever heard that? So
Maybe.
is that right? If they had lengths of 3, 4, and 5? 3 squared is 9 plus 4 squared is 16. That's 25 square root. Your hypotenuse is 5, right? Cool. All right, so yeah, so like a 3, 4, 5 triangle, that's like a right triangle. But again, this isn't just talking about right triangles, this is talking about any kind of triangle, right? So we know that that's a valid triangle. We can use that to test with. How about 1, 2, and 3? Well, I know from experience that 1, 2, 3 will not form a valid triangle, okay? And it follows that rule, right? So let's just kind of test this and see if that works, and see what the problem is. Here's 3. So I know that I know that 1, 2, and 3 is not a valid triangle, right? So if I were to do something like, it depends on kind of what order the sides are in, right? So what did I say, 1, 2, and 3? So if I did it like 2, 3, and 1, it'll tell me that's a valid triangle. But what if the sides were in a different order, like 1, 2, and 3? No, actually works. Let's see. Oh, because that gets down to the bottom part. But actually, what was I doing a minute ago? So what did I get when I did 3, 2, 3, 1, right? It tells me it is a valid triangle, right? So that was the problem. So it's the same numbers, right? I just put them in a different order, and it told me it was a valid triangle when it's not a valid triangle. So what's the problem here? How do I fix this? So
Specify which sides are.
right, or we've also got those logical operators that we can use and to test the different orders, right? Right, kind of thing. So so it's a valid triangle. So the rule was any two sides has to be greater than the third side, right? So let's test those 3 different scenarios. If S1 plus S2 is greater than S3, that's one scenario. So that has to be true, but at the same time, the other 2 scenarios have to be true as well. So what are those? If S2 plus S3, that's got to be greater than S1. And what's the other one? S1 plus S3 has to be greater than S2. See what I did there? And so that one, I think it might make it a little more readable if I group things. Right. So all 3 of those things have to be true at the same time. And that takes care of whatever order that I have, right? So S1 plus S2 is greater than S3, and S2 plus S3 is greater than S1, and S1 plus S3 is greater than S2. Does that make sense? So I can test that with my 1, 2, 3 combination. 1, 2, and 3, not a valid triangle. 3, 2, 1, still not. 2, 1, 3, still not. So it works. Does that make sense? So that's what we're going for there. I'm out of time for today. So that's all I'm gonna do on this. But next time we meet, we'll continue with this, and I'd also like to show that there's other ways that you can write a logically equivalent statement to this. So, and because people's minds work differently, right? So, kind of what we're talking about here is what we call thinking computationally, right? So, thinking like in a logical order with logic behind your thinking, and that's always a good thing in life. Okay, any questions about that? Oh yeah, so let's test to see if we can actually get something that's valid. So we know, like I said, we know 3, 4, 5 is valid, right? So try 3, 4, 5. So that's a valid triangle. All right, good deal. Oops. Or 4, 5, 3. No, not that. Anyway. All right, that's it.